So what we're going to talk about today is two things. First, we're going to talk about the use of broadcast receivers and explain how those can be used to implement our download service. And then we're going to talk about the concept of pending intents, which are a little bit more broad mechanism for being able to communicate back and forth between various services and activities. As you'll see, you can use broadcast receivers and pending intents to communicate from activities, from services back to activities, from services to services, all kinds of different combinations therein. So let's go ahead and start. The first purpose here is to discuss how we can use broadcast receivers in order to communicate back from a started service to the activity that invoked them in the first place. As we'll see here, we can use these broadcast receivers as a way of being able to communicate with potentially multiple processes without having to use the Android Interface Definition Language, AIDL. We'll talk later about AIDL, a very powerful and interesting mechanism in its own right, but we'll cover that at a later point. And I will go through this very complicated diagram one step at a time so you can kind of see how all the pieces fit together. So first, let's talk a little bit about what broadcast receivers are in the first place. They're essentially components, just like a service is a component, an activity is a component, a content provider is a component, that can be used to register for broadcast events and then receive and react to those events in some way or another. And you'll see that they're used very heavily throughout Android. One example is in the system service, which registers for broadcast intents on various things. There's also things like the phone application, which registers for broadcast intents on various things. And I'll show you some examples here in a second. But the idea is that these various services or activities or whatever, they register for these intents. And when something happens, then this thing called the Activity Manager service is responsible for actually disseminating the intent to one or more receivers, depending on various properties, like did they match filters that were provided by those receivers. And you can take a look here at this link for lots and lots more information about broadcast receivers. The events themselves are implemented as intents. So we'll talk more about intents later, but for the time being, just think about an intent as a data structure that keeps track of several pieces of information, keeps track of the action that you want to have performed, like launch an application, for example. It also keeps track of some data that's associated with that particular thing that's occurred. Maybe it's a path name or a URI or something. And it also keeps track of other kinds of information, categories and other types of things that can be used for various purposes by the Android filtering system. So for an example here, let's assume that we've got a battery service that's going to keep track of how much charge is left in your battery. And it's going to go ahead and detect whenever the battery is getting low, and it's going to turn around and then it'll broadcast an intent that says something to the effect that the battery is low, and that intent will be delivered from the service that's monitoring this, which, by the way, doesn't have to be written in Java. It could be written in C or C++ or some other language. That gets sent out via a broadcast mechanism called send broadcast or send ordered broadcast, as we'll talk about later. And that actually gets delivered through the Activity Manager service, which keeps track of all the interested potential receivers. And we'll see later that there's different kinds of receivers. There's receivers that are dynamically registered. There's receivers that are statically or implicitly registered. And you'll see different variants in that as well. When the events occur, the intents are disseminated by the Activity Manager service to all the various broadcast receivers that have registered for that type of an intent. This is a very, very common mechanism that's provided in most, if not all, operating environments, especially smartphones or user interface environments, as a way to be able to notify interested parties when something happens in the system. And Android is no different. The difference with Android is the degree of sophistication that they have built into the intent propagation system, which is called the intents framework. And it's very intense. Intents are intense. And we'll take a look at some of the ways in which the code works. It's an absolutely mammoth implementation. This Activity Manager service, which is the heart of this whole thing, is large, and you're unlikely to ever need to decipher the whole thing yourself. But it's kind of fun to look at it and see some of the patterns that are implemented. A couple of patterns that are implemented in there are, of course, the observer pattern, or its variant publisher subscriber, as well as various proxy patterns and other kinds of patterns. When an event or an intent is sent to a receiver, it shows up via the receiver's onReceive hook method. So if you want to receive an intent, when you match, then you'll fill in onReceive, and that onReceive method then does something in response to the intent coming in. As we'll see later on, there's a bunch of limitations and restrictions placed on what you can actually do inside of an onReceive method. You can't do everything inside there because of the context in which it runs. Notice also, by the way, that you can have multiple receivers for a given event. And depending on how the events are started, they may all receive the intents. All the receivers may receive the intents asynchronously, or they may receive them synchronously one at a time by something called ordered broadcasting. Typically what happens here, not always, but typically the way things work is that activities go ahead and they create receivers that are going to register with the system, the underlying activity manager service, through a context by a method called basically register receiver. That's one way to go. There's a couple other variants of this as well, but somebody figures out how to register for events. And there's basically two different kinds of events. There are system events, things like the battery is low, and those are things that are managed for you by the underlying Android system. And then there are also application level events, things that you create yourself as a result of what you're doing. For example, we can use this for the download service that we're writing here for various kinds of things. If you take a look at this article by Lars Vogels, he has some nice discussion about what broadcast receivers are and has some examples to program and so on and so forth. So it might be worth taking a look. His tutorials are generally interesting. They often assume a fair amount of knowledge of Android in order to be able to make sense out of them. They're not really step-by-step, point-by-point, but it's a good starting point, and you can often learn about a lot of good ideas by reading the stuff that he's written. Now, going back to what we were talking about before. So receivers are often somewhat restricted in what it is that they can actually do when intents are received. In particular, they are not allowed to show anything that's going to involve dialogues with the user. They can't bind to a service. Does anybody know why there are restrictions on what receivers can do in the context of Android? So the main reason is that they're not expected to run for very long. When an onReceive method is called back, the expectation is it's not going to block for very long. And so as a result, if you start doing things that require user interaction, or you start doing things that involve binding, by the time you get around to completing those operations, the receiver probably should go away. And so you don't want it to block for extended periods of time. And you can take a look here. There's some documentation that talks about the life cycle activities that pertain to receivers. Okay, any questions about that? So there's a couple of different ways to register receivers with the system. And these go by various names: static registration versus dynamic registration, or implicit intents versus explicit intents registration. There are a couple different names. We'll call them static and dynamic here for various reasons, although static is somewhat at the eyes of the beholder. Basically, one way to do it is whenever an application is loaded into the system, it can specify in its Android manifest.xml file a number of different directives that will indicate what kinds of things it does. You already know activities get put in there, services get in there. Well, something else you can put in there is something called a receiver. And if you register things as receivers in the Android manifest file, then that gets pre-computed statically, although again, keep in mind static is after the phone starts to run. And so in that particular case, it's more static than when an application is launched, but it's something that's done ahead of time. And part of what happens is the package manager service will parse the manifest file and extract out all the various kinds of receivers and take a look at the various kinds of intent filters that those receivers designate. And intent filters are a very powerful mechanism that Android's intents framework uses in order to be able to disseminate the appropriate intent to the appropriate receivers of that intent. And this is done in a very late binding way. In fact, you can actually have multiple matches, in which case Android will pop up a little dialog and let you choose which receiver you really want to have handle a particular intent. So if you take a look at this particular example here, you can see that we have a name. It's the phone app notify or notification broadcast receiver. That's the name of the broadcast receiver. That would be a class that would inherit from broadcast receiver. And you can see here it's not actually exported. It stays within the context of the phone app. So it's something that's used internally. And there are various security reasons for trying to do things like this. And over here we put in some of the various intent filters that are going to be used by the system to match whether an intent gets delivered to this particular receiver. So if the action is the send MMS from notification, if that's the intent action, then this particular thing will match that intent action. Likewise, hang up ongoing call. That's another thing that's generated, and so this particular receiver will get notified when the ongoing call gets hung up. So these are ways for various parts of the system to communicate with each other in a strongly typed yet loosely coupled manner. We'll talk more about this later. It's one of the most interesting things and most novel things about the way in which the Android architecture works is this very late binding property it has between how you start stuff up, or how things occur, and how you start up the appropriate application or service or whatever in response to that thing. Another way to do stuff, which actually, by the way, if you look at the phone app, which is where we're getting this code from, if you take a look at the phone app, you'll see examples both of statically registered servers and services and receivers, as well as dynamically registered ones. You'll see that there's also situations where they dynamically register for various kinds of intents. So if you take a look at the code, there's actually a whole pile of different things that occur at this point. But what happens here is we have this thing called a phone app broadcast receiver, and this particular thing has registered with it a bunch of intent filters, one of which includes the airplane mode changed filter. So if airplane mode changes, then that's going to be something that this guy wants to know about. And so after that filter, and plus a whole pile of other filters are created, then we go ahead and we register this receiver, the phone app broadcast receiver, gets registered with the system using this particular intent filter. So just again to illustrate how you can hook all these things together, either statically when the phone is downloaded from the Play Store, or however you load it from your debugger or your Eclipse IDE. You can do it statically through the manifest file directives like receiver, and or you can also have things that are registered automatically, dynamically and explicitly in your code by calling the register receiver method. Now, for your particular application that you're doing for this assignment, I strongly recommend you use the dynamic version. It just makes things a little cleaner and easier to do. Now, there's a couple of different ways that Android can actually go about sending out the intents or the applications that use this stuff, like a service, for example, or an activity. There's a couple of different ways that they can disseminate intents. One way is to send it with so-called normal mode. And normal mode uses an API call known as send broadcast. And this is an asynchronous call. What happens is if you have a send broadcast call, then all of the receivers that have registered for that particular broadcast, all the different receivers whose intent filters match some property about that particular intent, they will all get notified concurrently or in parallel. Now, how concurrent and how parallel that really is depends on a variety of things. It depends on, does your phone have multiple cores, how is Android programmed in the version of the phone you're running in, etc. But from a logical point of view, you should think about all these things receiving the data essentially at the same time. And you have not a whole lot of control over how that happens. If you look at the intent, the Activity Manager service, you'll see all the propagation, and it just goes through a big loop, and it says, send, 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 send to everybody. And it doesn't block waiting for the responses. So that's how it works for normal sending. So for things where you just want a bunch of people to be notified, and that you don't really care the order in which they were notified, and you don't really expect to get a result back directly, then normal send broadcast is the intent propagation API for you. There are other situations, though, where you want to do things in a slightly different way. This is not as common, by the way, as doing the normal approach. This is called the ordered approach. So in the ordered broadcast approach, what you do is you do send ordered broadcast, And if there are multiple receivers, then they get sent the request one at a time, sequentially, one after another. And the system will wait until the first one is done, either successfully or failed, in order to send the next one out. And the other thing to remember is for all the stuff that's done statically, in other words, where you registered it via the Android manifest file, those things are always dispatched using the ordering mechanism. And the reason for that is they don't want to go through the trouble of starting up all these processes and making a huge expense of starting all the processes. So it starts one process, delivers the intent. Starts the next process, delivers the intent. Whereas with the explicit intents, the ones that were registered dynamically, then those are typically delivered in mass using the concurrent version. So those are kind of the two different models. I would say people tend to use send ordered broadcast very, very, very rarely. You can also get a result back when you send ordered broadcast. The guy who's the last one to handle it can basically say, I'm done, and then a result will get sent back to the original sender. So if there's like a, kind of a bucket brigade or a chain of responsibility like pattern that you're trying to use, then send ordered broadcast may work. If you want to amuse yourself, do some grepping and finding and searching in the Android source space, and you'll find out that there's just a handful of places that use send ordered broadcast, but lots and lots and lots of places that use regular send broadcast. Okay. Yes?
So if you call like a start intent on some intent, does that implicitly send out a broadcast to someone then?
When you say start intent, or what do you mean?
If you like create intent like in a first project and call start intent, and that can either call like the Google Maps API or something else, does that create a broadcast that sends out to them?
Good question. So I think what you meant was like start activity, start service.
Yeah.
Right. So you create an intent, and then you say start something or other, right? So in those cases, those things are actually handled by the Activity Manager service, but they are a different path through the code. So when you do a start activity, it goes through the Activity Manager service, but it'll pick one activity from there. It'll pick the right one based on a variety of things, and then it'll go ahead and send it to that. So, and it may have to prompt you and say, do you want to use Google Maps? Do you want to use the browser? Do you want to use something else? So the activity stuff also runs through all the filtering, just like the broadcast receivers. But the main difference is when all is said and done, one of those guys will be picked, and he'll get the activity delivered. Same thing is true for services. When you say start service, the Activity Manager service handles all that stuff internally. It does the filtering. It finally picks the service and starts it. But only one is picked. In contrast with the broadcast receiver, if there are multiple things that match, they'll all get them either concurrently, as is the case with the regular broadcast, the normal broadcast, or may get them one at a time using the ordered broadcast. So yeah, the main difference there is many being delivered versus one. That's the main thing. And of course, the other main difference is that when you start an activity or a service, the properties of that activity or service are a little different. For example, when you start an activity, it has the ability to access GUI widgets and do dialogues with the user. If you start a service, it has the ability to bind to other services and so on. Whereas broadcast receivers have a more narrow range of things that they're allowed to do, because they're basically just a callback that kind of pops out of nowhere, and then when it's done, it's meant to be a short-lived operation. That's a really good question. Any other questions about that? All right, what I'm going to do now is I'm going to show you how someone might implement a download service using broadcast receiver. And we're going to step through it sort of a little bit at a time, and we'll do a set of builds so you kind of see one thing after another. So in this particular case, we're going to create a download activity, which is going to create and register a broadcast receiver. And this broadcast receiver is going to be used by the download service. So when the download service is done downloading the file, it can broadcast back to the activity and say, I've completed the activity, here's the information that you requested. So that's the big picture view. So first we're going to kind of step through this one little step at a time and show it visually, and then I'll go and show you a few code snippets of how the whole thing works. All right, so we're going to have a download activity, and it's going to have a couple of methods. It's going to have an onCreate hook, like always, and then onCreate hook will go ahead and create a broadcast receiver. There's other ways to do this, but we'll just do it this way for fun. It'll create a broadcast receiver, and then when the onResume method gets called, and you'll see why we do this in onResume later, we're going to go ahead and create an intent filter that has the appropriate kind of intent, says, this is how you get the data back to me when you're all done. And it goes ahead and basically registers that intent filter and the broadcast receiver with the context of the activity. So from the context, from an activity, all you have to do is just say register receiver. And because an activity is a context, then it inherits the method. In fact, there's about 35 methods that you get out of the box with services and activities that come from context. One of the least well understood and least well explained characteristics of Android is what the heck is this context thing and how do you use it? It's somewhat mysterious and not very well documented. Okay, so we go ahead, we create a broadcast receiver, and in the onResume method, we're going to go ahead and register that receiver. By the way, does anybody know why we register the receiver in the onResume method as opposed to doing it in the onCreate method?
Because onResume gets called after onCreate.
OnResume definitely gets called after onCreate, that's right, but why?
Because if you pause it and then re-resume it, onCreate isn't going to be recalled.
Right, so the way it works is if you pause the service, then the onPause method gets called. And as we'll see later when we actually look at the code, when the onPause method is called, it's going to remove the receiver. It's going to unregister the receiver, so it's not sitting there doing anything while the service is paused. We don't want to deliver it while it's paused. So you'll see when you come back and re-resume, then you have to go back again and re-register the receiver to get called back. Okay, the next thing we're going to do is we're going to go ahead and we're going to create an intent. And in this case, this particular intent is going to store the URI that we want to download as an extra. So we're going to stick that in as an extra. Actually, I guess we could actually store it. Let me tweak that a little bit. We could store it as data. That's probably a better thing to do, as data. There's a couple of different things you have in intents. You have data, which are typically used for URIs, and then you have other stuff, which could be URIs or strings or messengers or whatever, and those things get stored as extras. So typically if you're going to send like a URI, then it's a good idea to make that be data, and that way things can filter on that if you have some reason to want to filter on those kinds of things. You have a special, like a Maps URL or something like that. People will subscribe to the Maps API, for instance. In our case, we're just trying to download the file, but the point is more broad. Okay, so we create the intent, we set the data, we set the extras, whatever we're going to do, that's been connected in there. And then the next thing that we do is we go ahead and we start the service. And that's what we were talking about before. When you call start service, you give it an intent, and that intent indicates something about how to find the service, and it also indicates the extra or the data that we want to pass along. Now, as you guys may all remember, we're going to assume for the sake of this discussion, we're implementing this using our download service, which is a little different from what you guys are implementing, just to make it more different. So it's not a complete cut and paste. But the download service, if you may recall, was a service, and the download service went ahead and used that Android idiom where it spawns in the background a service record. So what happens here is we create a process. In this particular case, we're going to assume that we're creating the service as a process. So we go ahead and create a process, and that guy's going to run the download service. Its onCreate hook method gets called. Its onStart method gets called. The onStart method is going to go ahead and create the service handler, or maybe the onCreate method does, either one, as long as the service handler is running with a thread in the background. And then onStart command is going to go ahead and take the intent that was passed in, and it's going to go ahead and send that to the service handler that's running in the background. So this service handler that's running in the background is actually going to do the real processing. And what he's going to do, of course, is he's going to take the intent that was sent, and then the thread that runs in the background will dequeue the intent, and it'll go ahead and download the file at that point. Now, there was some interesting discussion on the mailing list. I wanted to just clarify some interesting things because we had some good questions that were asked earlier. So if you read the Android documentation, it has this, about async task, it has this somewhat cryptic comment that you can only use async task in the UI thread. And so the question was, can we use it inside of a service? Because your programming assignment that you're working on now, the next one, has you implement a service that uses async task. That's one of the four models. So the four models are basically to use a messenger, use a intent service, use async task, and then I think there's a thread pool one in there as well. So there's like, and there's pending intents figure in here too. So there's 4 different ways of doing it. One of them involves an async task. So the question was, can you call async task in the context of a service? And the answer is yes. Because remember, by default, a service runs in the main thread. And so it's perfectly fine to call execute on an async task as long as you're in the main thread / UI thread, main thread and UI thread being synonymous in this particular case. And so if it's a service that's running in the same address space as the invoking activity, the service is still in the main thread. And you just have to make sure that you don't end up trying to, as always, you don't end up trying to do UI calls from the background thread. That would be spawned by async task. If you've created your async task and your service to run in a separate process, it will also have a main thread. Whether that's connected to the graphical part of the graphical user interface, there's still other things that you can do, like you can do vibrates and other kinds of things that are user interface driven. So if you start an async task in a process that's running in the main thread, then again, you can use async task. You just have to be somewhat careful in that case. You don't try to end up doing display operations from the background thread running in that other process, or from the foreground, the main thread in that other process. So just be aware that you can in fact do that. And the documentation is just a little bit squirrely about this, but as you'll see when you try it, it should work. If it doesn't work for some strange reason, let me know, but I think it'll probably work, no problem. Okay, so when we're done downloading the file, we're going to stick the file in the file system someplace. And then what we're going to do is we're going to go ahead and we're going to do a send broadcast. And we're going to broadcast the path name back to whoever subscribed to this. And when we see in the actual code of this in a second, you'll see we do a few little tricks to try to make this as secure as possible. We want to make sure that you don't have people sort of intercepting your broadcasts, people you don't expect to be doing this. You want to make sure that you're getting, you as an activity, you want to make sure you're getting a broadcast back from just the guy that you started and nobody else. So we'll kind of see how that might work. The Activity Manager service runs in a separate process. This is managed by the system, the service, by the Android system. It's a separate process that runs. And when you do a send broadcast, it sends the intent over there and does a whole bunch of things to it, which we'll talk a bit about later. But for right now, the main thing to know is that it's got this call that goes ahead and sticks the intent, takes a look at the intent that you sent, and then tries to figure out who's a receiver. And once it figures out who's the receiver, it goes ahead and sends the intent onto it asynchronously. And what will happen there is that will ultimately end up dispatching that intent back in the activity class in the onReceive method. And what it'll get back at that point will be the path name that corresponded to the file that was downloaded by the download service. And then it'll go ahead and display that image, and you'll be done. Okay, so those are kind of the steps that are involved in doing broadcast receiver. Any question about that? And they're usually more or less some variation on this theme. Okay, so let's talk about how we might actually program this thing. So we need to be able to have some kind of broadcast receiver, I guess, to be consistent with the code that we showed earlier. We'll go ahead and put this stuff into let's see. We'll put into onCreate bundle on saved instance. And we'll say on event. Just putting in here, let me play around with these things a tiny bit. I'll come back and fix all the formatting a little bit later. But the basic idea here is that somebody, either created statically or in the onCreate method, is going to go ahead and create a broadcast receiver. And his onReceive method, when called back, is going to go ahead and extract the path that came back from the download service as an extra within the intent. And then it's going to check to see whether you actually downloaded stuff. And if not, you'll print out a toast that indicates a problem. And when you're all done, you'll go ahead and display the image. And you'll give the path name to the display image function, and that'll go ahead and do what it needs to do to open the file and display the image. At that point, the file should be in the file system if you downloaded it properly and installed it in the right place. So that shouldn't take long. That shouldn't block the main thread for any length of time. And so it's probably OK to go ahead and do this in the onReceive callback method. If for some reason that was going to take a long time, then what you would do is you would end up having this onReceive method go ahead and send the data to run through a post a message or a runnable or something back to the UI thread. So it'll go ahead and do it in that context. If for some reason the callback to onReceive was not going to work properly. But that shouldn't be a problem in this case. OK, yeah, Sean.
What is the context that it gets in the onReceive?
It's really the context of the handler of broadcast receivers. And that is not necessarily the same context as the main thread of control. It could be a separate thread. In fact, it probably is a separate thread of control. So it'll be the context of whatever thread is running there. And that was what I was talking about before. You can't really rely on that living, you don't want to block that for any length of time. You don't want to be blocking the onReceive callback because its context is not a blocking context. So it's probably a separate thread that comes out of a pool of threads. In fact, a fun thing that you might want to do, no, I take it back. It's got to be the main thread, but it's not the activity context.
Okay.
So this is part of the mysterious aspects of Android with contexts that are not really clear what they do. OK, the next thing, this goes back to the conversation we had before about onResume and onPause. So remember, onResume is what's going to get called back right before your app goes live and displays on the screen, or as it's displaying on the screen. So what we're going to do here is we're going to go ahead and create an intent filter. And we're going to say, we want to listen for the action complete intent, which we can create. And then we go ahead and register ourselves with that particular intent. And when onPause gets called, if for some reason we lose focus, the user switches to some other activity, in that case, we need to explicitly unregister the receiver, remove it, so it will not be dispatched while the application is paused. That would be a bad thing. So that's why we typically do these operations in onReceive and onPause in order to register and unregister the receivers. OK, the next piece of the puzzle here, now this is the method that's going to actually initiate the download. So this is typically something you would connect to a button that you would have on your user interface. So initiate download is going to go ahead and create a new intent that's connected to the download service. It's going to go ahead and stick what's called the package name into the intent, and you'll see why it does that later. We're basically doing that. Well, let's see. So we use the package name here as an extra so we can make sure that only we get back the broadcast from that particular intent. There's a way of restricting it to just go back to the package name. Once that's all been set up, we then go ahead and start the service, passing in the intent. Keep in mind that the other thing that it'll have here, of course, will be the data that corresponds to the URI that we want to have downloaded. Let me go ahead and start the service. Here is the service itself. So download service, extend service. This is not quite the way your solution works, but it's along the same lines. We have our download image method that does what it does. Again, there's lots of different ways to do this. You might want to keep your download image method very simple and not have it do anything complicated except download the image. In this particular case, I'm having it download the image, and then I'm also putting some additional code at the end. And so you can see here what I do is I go ahead and I create a new intent which corresponds to the same intent that this guy over here was listening on. So you can see he created an intent with the action complete name. And then down over here, I'm making a new intent with the action complete name. I'm sticking the result path, or the path name for the file I downloaded. I'm sticking that as an extra into this intent. And then I'm taking the intent, and the original intent that I got here, and I'm looking up the package name, which is stuck in there over here. If you take a look here, I stuck this in the package name when it was sent off in the first place. And then I'm saying, only send this intent back to somebody with this package name. So it's just a little bit more attempt at trying to make sure only I get this stuff back. I don't want to be just giving it back to anybody. I want to give it back to the guy that started me up in the first place. So we're restricting the target of the broadcast. And then the last thing we do is we go ahead and we broadcast the path name back to the activity. So what that's going to do is that's going to go ahead and get that back to the activity and deliver it back there through a call through its onReceive hook method, which was the one that we saw over here. And as you can see, onReceive takes the path name, extracts it out as an extra, and then goes ahead and displays that image. OK, any questions about that? About how the code works or the overall design? So here's the thing to remember about this stuff. So broadcast receivers give you a very powerful and scalable framework for being able to send intents to various receivers, potentially running in multiple processes. Most of the time you use them, they're not used for this kind of use case. In fact, well, let's talk about that. What are the pros and cons of using broadcast receivers in the way that we're doing them here? Is this the right solution for the job? And what would be some alternatives? What would be alternatives to using broadcast receivers? What did we talk about last time we had class that I taught? Messengers, right. So the other approach we talked about before was the messenger approach. What's the main difference between a messenger-based approach and a broadcast receiver-based approach?
Broadcast receiver is going to go through an intermediary with messengers going directly back to it, right?
Great point. So the observation here is that messengers are kind of point-to-point, and broadcast mechanisms through the activity manager service is kind of a point-to-multipoint, at least potentially, right? And so what we're doing is we're kind of hijacking this point-to-multipoint mechanism, which is pretty complicated, quite frankly, and we're using it for something that really is point-to-point, because all we're trying to do is get this path name back to a particular activity. We're not trying to tell the whole world that we've downloaded the file. We're just trying to tell one guy that the file you wanted is done. Come get it, right? Or come look at it. So that's probably one of the best arguments in favor of using something like a messenger, because the messengers are point-to-point, whereas the broadcast receivers are more powerful than that. So even though they can be used for much more interesting use cases, like just informing the world, hey, anybody who cares, battery is low, which is a good use case of the broadcast receivers, in the case of point-to-point communication, it's probably overkill. Any other thoughts about messengers versus broadcast receivers? So we'll talk about some of the other implications here in a second. One of the big issues is security. So let's talk about this. There's a bunch of different subtle issues with security having to do with broadcast receivers. One of the problems with security is the fact that the intent namespace, remember, intents are how you communicate with broadcast receivers. You send a broadcast to an intent which has some global information in it, like its action and other kinds of things. That the namespace for intents is intentionally global. And so as a result, that can mean that you've got conflicts. If multiple people sort of register for the same thing, not realizing that there could be multiple parties who receive them, that could lead to you getting notified for things that you don't really care about, which can be very confusing. The other problem is that register receiver allows any application to send broadcasts to that registered receiver. So you can kind of sneak along, and if you're not careful, in other words, you don't use permissions properly, the system will be overly permissive. It's kind of like, you know, hippies in Haight-Ashbury, right? Hey man, anything goes, you know. And so as a result, you have to be careful, because people can be registering for things and you don't really want them to receive it, but everybody's going to get it. Some ways to solve this problem, of course, are to use permissions, use some of the other stuff we talk about, like set package names and so on and so forth. And there's a lot more good stuff on this. You could also basically override the filters. People can listen to stuff. They can superimpose their will over top of what's built into Android. And so one thing you might want to do is just not export out the receiver. So it's only part of that particular app. It's not exported to other parts of other apps, just that particular app. And there's discussion of that here. And the other thing, of course, is that send broadcast allows any other app to receive the broadcast. So you can restrict that by using the concept of setting the scope or the target with the package name, which is why we did that before. So broadcast receiver is very powerful. It's probably too powerful for this particular use case, but I wanted you to be aware of it, and it is heavily used throughout Android in order to get alerts and alarms for various kinds of things when something has happened. And there's sort of two different uses of these things in Android. One is to tell you that an event has occurred, and another is to tell you an event is going to occur. So you can kind of deal with things in different ways. Okay. Any questions about broadcast receivers? So that should give you more than enough information in order to do that part of your assignment. It should be pretty straightforward to do it. Next topic is even more interesting and even more complicated, and has even more moving parts. Now, your book talks about using what I'm about to describe as yet another way to communicate from services back to their calling activities. And you can certainly use it that way, and you're going to get a chance to use it that way. That's not the most common use case for it. By far, a much more common use case would be something like a messenger, if you're just trying to talk back to one particular thing. So we're going to actually talk about this next concept, which is called pending intents, in a little bit broader scope. We're going to talk about how we can use pending intents to have one component, say an activity, create something called a pending intent, which is a token, and then it's going to pass that pending intent or that token to somebody else. And that somebody else is going to use that pending intent in order to start either that activity again or some other activity when something interesting happens, like the passage of time occurs, or you click on the notification status bar icon or something like that. So what this is going to be about is about deferring processing to some point in the future when things can occur to your liking. And in order to motivate this, we're going to talk about a couple different things. I'll start first by just talking about how it's commonly used in Android, and then I'll talk about an extension to the download service that you guys are writing called a deferred download service, where we could really take maximal advantage of what I'm about to cover. So what is a pending intent? Pending intent is basically a token that's given by an app to some other component, and when it gives it to that other component, it basically says, I'm giving you delegate authority. I'm giving it what's called plenipotentiary authority. You can do things on my behalf, right? I'm giving you signature authority for me. And so it hands it to this other entity, and then at some later point, that entity wants to do something, it does it, but it's as if the original app was doing it, not the other entity. So the most common cases where this gets used in Android are for things involving the alarm service and the notification service. So for example, if you take a look on your phone, you'll notice you have this notification area, and if you go up there and touch it and kind of slide it down, it comes down like a tray, and then you'll see this notification drawer, and there's a bunch of notifications in the notification drawer. And you can click on that notification in the notification drawer. You can click on an icon or some symbol there, and that will go ahead and launch an activity or service or whatever to carry out some operation on behalf of whoever put it there in the first place, whoever the party was who did it. So a common thing would be whenever you receive email, rather than just interrupting you and throwing it up on the screen, instead it puts it up in the status bar, the notification area, and then you can go there and say, aha, I got mail. You know, your phone will buzz or blink or something. You can come up there and say, oh, I got mail from so-and-so. I'm going to read that. Click, you touch that with your finger, and that'll start up an activity where you can read that particular mail. So the way it's done here is that that's deferred, and what's put in that notification area is actually a pending intent that can be used to activate the actual component, activity, service, broadcast receiver, or so on. And so we'll see there's lots and lots of different things that work here. Now what's particularly cool about this is this will work even if the activity that started up the original operation no longer exists. And so I'm going to talk about that in a little detail later and show you some examples of how it all works. Now, pending intents are complicated, and there's a lot of different ways to create them depending on what kinds of actions you want to have them do on your behalf. So keep in mind that basically a pending intent is a way of associating an action to run in the future on some intent. So we're going to talk about 4 different ways of creating pending intents. The first 3 of these are actually part of the pending intent class itself. They're static, they're defined as static methods, static public methods in pending intent. And they are getActivity, and getActivity is used to return a pending intent that will start an activity when send is called on it. We also have getBroadcast. That'll give you back a pending intent, which when you call send on it, will start up a broadcast receiver to handle that intent. And then finally, getService. And what getService does is it goes ahead and starts a service up when someone calls send on the pending intent. So there are 3 different ways of launching 3 different kinds of components: activities, broadcast receivers, and services using a pending intent. And as part of the thing you pass in there, you pass in the intent that you want to have delivered later to the component when it gets started at some deferred point in time. So those are the 3 things that are defined on pending intent. Then there's a 4th way of getting a pending intent, and that's via a method that's actually part of activity, and it's called createPendingResult. And when you call createPendingResult, you get back a pending intent, which you can then pass on to somebody else. And when someone calls send on that thing, it goes ahead and sends back the data through the onActivityResult method of that activity. Now there's some constraints here. That activity needs to be running in order for this to work. So it's a little bit more limited. But there are some interesting use cases we'll take a look at here in a second. OK, so those are the 4 different ways you can do pending intents. For your application that you're doing for your assignment, I would recommend you use createPendingResult. That's probably the one you want. All right, I'm going to take a look at a couple of different use cases here, because these get used in a lot of different ways. The first one, we're going to do a very simple kind of timer-based approach. In fact, this is so simple that arguably you probably would never implement it this way. Instead, you would probably use some kind of a handler with a deferred message of some kind. So what we're going to do here is we're going to have an activity whose onCreate method will get ourselves a reference to the alarm manager. And then it goes ahead and it creates a reply intent and puts some data in it. And then it creates a pending intent result, which gets us back a pending intent, with that reply intent, with the extras. And then we go ahead and we say, hey, alarm manager, please set yourself up to get called back every period. Let's say periods every 5 seconds or 10 seconds or whatever. And then we say, and we're out of here. We're done. OK, so at this particular point, what will happen here is that when we call the setRepeating method on the activity manager, that will call the setRepeating method in the alarm manager service. And a lot of things will go on here, but not the least of which is that we're going to go ahead and make a new alarm, which is going to go off at a certain point in time. And we're going to stick when we want it to go off, what operation we want to call back, which is this pending intent thing. And then we stick that guy into a message handler for that period of time. So we say go off in 5 seconds. And the alarm manager is its separate service, so it can run whether or not your application is even around. Your application could have gone away at that point, as we saw here, and will be fine. So what then we're going to do is when the timer expires, the alarm service sends a reply back to the activity. So if you were to go look in the code for all this stuff in Android, you would see that there's inside the alarm manager, there's a thing called alarm handler. And when the handle message gets called back, that's because the time has elapsed. And we do a bunch of things, and we end up calling send back on this pending intent. And that will end up causing the onActivityResult method to get called back in that activity. And then it'll check and say, was that the alarm ID message that I'm getting back? And if so, it'll process it in some way. So this is a way of using pending intents in a very simple manner. This is very simple. That's actually not unlike what you're going to do for your application. So it's kind of along those lines. The difference being that you're not going to pass the pending intent to the alarm service. You're going to pass the pending intent to the download service. And then the download service will use that pending intent to send the result back when you finish downloading the file. Okay, so now I'm going to take a look at a much more sophisticated example. This is a really, really cool example. In fact, we might make it as a programming assignment in some version of this class at some point because it's so cool. So what we're going to do here is we're going to implement a deferred download service. And the idea of the deferred download service is you're going to give it a file you want to download, and then some point in time in the future when you want it downloaded, like download it at midnight or something like that. And the way that alarm services work, by the way, is your phone can actually be asleep, and if you start them in the right mode, it'll wake your phone up in order to be able to deliver the intent. So what we're going to do here is we're going to start out by creating an intent, which is going to be the intent to start the download service. And then we're going to go ahead and create a pending intent. And the pending intent stores the intent internal to itself. And then we're going to go ahead and we're going to use the alarm manager service to schedule this pending intent for some future down the road. So it says, in 3 hours, run this thing. And so that goes in and it sets that in the alarm manager service. And then at some point, 3 hours later, when the timer goes off, the alarm manager service wakes up, and then it goes ahead and sends the pending intent. And our pending intent in this case was to start a service. So it was the get service version of pending intent. The service is now started up. It's running a thread in the background. It goes ahead and processes the intent, finds the path name, or finds the URI, downloads the file, sticks it in the file service, and so on. Now, here's the big question. How does it notify the user that the file has been downloaded? Because the user may be asleep at this point, literally, right? It's a deferred download, so there's no reason for the user to sit there like your app with the application still up, so you can go ahead and just return it back when it's done. So how are you going to get that back to the user? Anybody want to take a guess? So the trick here is to use the notification manager service. So the notification manager allows you to be able to give it stuff to do, and what you do is you end up calling notify. You do a bunch of things with a thing called a notification builder. You build up a notification and you say, hey, notification manager, notify. And depending on what you've done, that may cause the phone to vibrate or lights to flash or something to happen or a bell to ring. And what will occur is in the status bar, it will then go ahead and indicate that there's something that's happened. And you can dictate what that something is. You can put an icon, for example, up there that indicates mail has arrived or whatever. And then the user comes along, and if they choose, they can drag open the status bar, notification bar, and in there they will then see all the things that have happened. And one of the things that would happen in this case would it say download complete, right? And so you would end up clicking on that download complete, and what that would end up doing is when you click on the download complete operation, or you click on that button, a click handler gets called back, and that goes ahead and calls send on the pending intent. And the pending intent then goes ahead and does whatever it needs to do. In this particular case, we might have another activity unrelated to the original one, the one that originally did the deferred download. This might be called view download activity. And view download activity would go ahead and take the path name of the file that sits in the file system or wherever it sits and goes ahead and displays it on the display. So this is a super cool example because it illustrates how you can use pending intents multiple places. Notice we used pending intents over here in order to be able to create something that we can have generated under timer control. So when a timer goes off, that'll cause the intent to fire, which will start the service. Over here, we can download the file, and when we're done, we'll create a pending intent, which we can then register with the notification manager. And when someone comes along later and goes ahead and selects that particular notification in the status bar area, that will then go ahead and trigger the second pending intent call to send to the intent, which in this case will go ahead and start off an activity to display the result. Any questions about that? Notice the very, very loose coupling in all these different things. Really, really cool. You decouple things in terms of time and space. You decouple these things in terms of sender and receivers. You could have many-to-many relationships about who can send stuff, who can reuse these services. So each of these activities or services can be developed largely independently of each other. And then you can arrange in conjunction with other cool Android mechanisms like Alarm Manager Service, Notification Manager, and so on. you can arrange to get things to happen at the right point in time, in the right context. Or you can just go ahead and glue them all together and have things work synchronously, right? So you could reuse this stuff. The deferred download service doesn't really know it was called under timer control, right? The view download activity doesn't really know it was called by the status bar notification manager mechanisms. So you could reuse those things in other ways and have that logic be much more fine-grained and much more granular and easy to work with. Okay, so then the last thing you do is process the intent and display it. So let's take a look at some of the code that we would implement here to get this to work. So we're going to have deferred download activity, which extends activity, and we'll have some kind of click handler, initiate deferred download. That creates a new intent, which is going to call the deferred download service class. It goes ahead and creates a pending intent, passing in that intent along with some other stuff, and it's saying, I want this guy to start a service when he's called. We then go ahead and get the alarm service, and we register this guy to wake up at some point in the future, and we send him the sender, which is the pending intent, and the time that we want him to run down the road. All right, so that's the deferred download activity. You could read more about this. Lars Vogel has a nice tutorial about pending intents that shows some of this stuff too. Here's the deferred download service. Remember, this guy's going to get called back when the alarm manager notices the time has elapsed and goes ahead and calls send on the pending intent that was stored in it. And what that'll do is that'll end up triggering the deferred download service, which let's say it's an intent service just for sake of argument. We'll go ahead and download the image, and then we'll do a bunch of things. We'll go ahead and create a pending intent to trigger if we select this from the notification bar in the notification area. We go ahead and create a pending intent that's associated with this particular intent, and we're going to register this with the notification service. Then there's a whole pile of gobbledygook stuff here. Let's see. There's a whole bunch of stuff here that's going to be called under certain circumstances. Let me do that. It's probably the fix. All right, there we go. So here's the second half of this. We then go ahead and use the fascinating notification builder mechanism that Android provides that lets you build a notification out of pieces, much simpler than the way you used to have to do it. So we basically say, I want the title of this thing to be image download complete. The text will be the path name. I want a special icon. And I want the intent to be the intent that we're going to use. This guy over here. Whoops, this should be called content intent. And so all these things are put into this notification, and then we say, notification manager, go ahead and register this notification, and that will cause it to pop up with the appropriate buzzing and flashing and whirring and music tones and so on that you've set also, which I didn't show here, but it's easy to add. And that'll cause that to show up in the notification area. You can then drag that down and go ahead and click on it. And when you click on it, then that'll end up calling the view download activities on create method, where you can go ahead and extract the various things you need, like the path name from the intent, and then go ahead and display the image.
Can you go back a slide?
Yeah, sure.
Second line from the bottom.
Yeah.
The bar and the. What is that doing?
So this is the OR assignment operator. It's the bitwise OR assignment. This is saying there's a bunch of flags that are set. It's saying please enable the flag auto cancel semantic on this notification. What that means is when you select the notification from the notification area, after you select it, it'll automatically disappear. You don't have to flick it off the screen and remove it. So the OR equal says OR in this bit mask into this bit mask flag. So that's just C++, Java syntax for doing bitwise operations.
Gotcha.
So that's the bitwise or operation with the assignment. So it's saying, take the current flags and add that flag and store it back into flags. Okay, so to kind of summarize this particular stuff, pending intents give you this very powerful framework that allows applications to defer processing until later in time, either later, literally later in time by using some kind of alarm service or something, or later in time being put it in the notification area because you don't have the application up and running, so you can't communicate back to it. So it's either in future in time or in a different context than it was originally invoked. And you can use it to communicate from a started service back to the activity that launched it, which is what you're doing for your programming assignment. But be aware that its real beauty and its real power come from more interesting use cases than that. That's not the world's most interesting use case. It's one use case, but much more interesting use cases is where you kind of lodge these things elsewhere to be used later to automatically start things up on your behalf, because you're the one who created the intent. Keep in mind it runs with your permissions. So whatever you do, it's kind of putting a ticking time bomb into the system. If you're not careful, you have to make sure that you actually want this thing to run in the future, and you want it to run with your permissions at the time it's going to run. It's a little bit complicated to learn how to program pending intents. They're not very widely explained. If you look around on the web, you'll see a handful of tutorials, but they're not covered in anywhere near the degree of depth as a lot of other stuff. But you find them used very, very heavily throughout much of Android and the Android applications and services and so on. Okay, any questions about anything that we covered today?